In this video we're going to look at a story problem involving direct variation. So let's see what we have here. The weight of a liquid varies directly as its volume V. If the weight of the liquid in a cubicle container 4 centimeters on a side is 128 grams, find the weight of the liquid in a cubicle container 5 centimeters on a side. Well, this is a multi-step process, so first let's take a look at what is meant by direct variation. So we're going to use this first sentence here to help us set up a formula. This first sentence is sort of a formula. It doesn't really give us any specifics. It's telling us a fact. The weight of a liquid varies directly as its volume. So if you have something that says varies directly, let's just do something really general. Let's say I have a statement that says X varies directly as Y. Varies directly means if X gets bigger, Y gets bigger. If X gets smaller, Y gets smaller. That's different than varies inversely. If something varies inversely, then as one thing gets bigger, it would cause the other thing to get smaller. Like let's say I had to share cookies with somebody, and if I got more, that would mean they get less. So those would vary inversely as each other. Something that varies directly would be if something gets bigger, then it causes something else to get bigger. Like let's say calories burned and miles run. The more miles I run, the bigger that is, the more calories I'm going to burn. So those vary directly. So that's just a general idea of varies directly. Now as a formula, whenever you see varies directly, you're going to include a constant, which I usually use K. We don't know how much, if one doubles, it doesn't necessarily mean the other one doubles. It just means it gets bigger. So I'm going to change this into a formula that says X equals K times Y. So I know that as X gets bigger, Y is going to get bigger, but I don't know by what factor. And that's what the K is. So anytime you see something X varies directly as Y, you want to set up this little formula, X equals K times Y. That's varies directly. So if we go up here, instead of X and Y, we have some specifics. We have the weight of a liquid varies directly as its volume. So the weight of the liquid is kind of like the X, and the volume is like the Y. So we need some variables for that. Let's let W be the weight of the liquid and V be the volume. So following this formula down here, we could say W equals K times V. And we don't know what that K value is. Okay, how do we figure it out? We need to figure out what that K value is. That's the second part. So part one, set up your little equation based on the statement. Part two, we're going to use a given fact. They're going to give us some fact here, some example. And here's our example underlined in green. If the weight of the liquid in a cubicle container 4 centimeters on a side is 128, and then we have something we have to find. So we know if we have a cubicle container, let's see if I can draw a cube, that is 4 centimeters on each side. That's pretty good. So 4 centimeters, 4 centimeters, 4 centimeters, that this is going to weigh 128 grams. Okay? So we can use this fact in order to find K. And then once we have K, we can go solve what it is they ask us to solve. So the whole point of telling us the stuff in green, underlined in green, is to find K. That's why they told us that specific situation. Okay, so here's our formula. W, which is the weight, equals K times V. Well, we know the weight because they told us that was 128 grams, so that's going to go there, 128. Now, what is V? V is the volume of this shape. All right, we got to figure out the volume of a cube. Hopefully you remember that is length times width times height. So the volume of this cube is 4 times 4 times 4, or 4 to the third power. So I'm going to plug that in for V. So the volume of this I'm going to plug in right there. Okay, so what do we have? We have 128 equals K times 4 to the third power, 4 times 4 times 4. Well, now I have an equation that I can solve. Pretty straightforward. 4 to the third power is 64, and then if I divide both sides by 64, I get 2. So there's my K value. Okay, now I can modify my formula. Based on this one example, I can take my general formula of W equals K times V, and this K value is going to be the same all the time. K for constant, okay? So W equals 2 times V, or 2V. I didn't have to put that little dot, but you get the point. So the whole point of giving me this example was allowing me to find K, which is going to be the same K in the next situation. Let's underline that in, oh, how about this hot color here? Find the weight of the liquid in a cubicle container 5 centimeters on a side. So we're finding the weight. We don't know the weight. Well, if we want to find the weight in this equation, W equals K times V, we're going to have to know K and V. We just figured out K, that's 2. So now all we have to do is figure out V, and now we've got a cubicle container 5 centimeters on a side. So I've got another cube, and now it's 5 centimeters on each side, so you don't have to draw the picture to get this, but sorry, that wasn't as pretty. What would the volume be if it was 5 centimeters on a side? 5 times 5 times 5. 5 to the third power. So I know the volume of this is 5 to the third power, which is 125. So I'm going to plug that in up here, and then I'll be able to determine the weight. So I know the weight equals 2 times 125, which is 250. And since my example over here was in grams and centimeters, those labels will remain the same, so this would be 250 grams. So it's really a 3-step process with these variation problems. The first part is to set up your formula right here. They're going to give you some statement. The weight of a liquid varies directly as its volume V. That statement is to allow you to set up the formula. Then the second thing they're going to do is they're going to give you a specific example that's going to allow you to find K. Then the third thing you're going to have to do is take that K value and solve some other question, or answer some other question that you have to know the K value to solve. I hope that helps.